हेलो एवरीवन। आप सबका स्वागत है मेरे इस वीडियो में। यहाँ पे हम लोग बात करेंगे अबाउट डिफरेंट इंपॉर्टेंट कॉन्सेप्ट्स लाइक बायस वेरिएंस। और जब हम लोग बायस वेरिएंस के बारे में बात करते हैं तो दो इंपॉर्टेंट कॉन्सेप्ट्स आते हैं, ओवरफिटिंग एंड अंडरफिटिंग। तो मेरे प्रीवियस वीडियो में आई हैव ऑलरेडी शोन यू द थियोरेटिकल एस्पेक्ट्स ऑफ ओवरफिटिंग, अंडरफिटिंग, बायस एंड वेरिएंस, and in this video I will show you the practical implementation of these using Python programming language. Moreover, before starting this video, I will tell you that these topics are very important because whenever you are training any model, you have to understand how well that model is getting trained. You have to check with respect to different kind of performance matrices whether that model is overfitted, underfitted, or whether it is a generalized model. For details, you can go to my previous video, check the theoretical aspects. Here I will be covering the practical implementation. So first of all, I will be generating few data and then I will be fitting it with respect to polynomials. So I will be using regression concepts. As I have mentioned earlier, that regression and classification, these two are the different kinds of problem statement, and we can address the issues of underfitting, overfitting, generalized model with respect to these two problem statements. Here I will be showing with respect to the regressions. So we will be creating a regression model which will be fitting our data, and that data we will be synthetically generating. So first of all, as you see here in this code, I will be giving you this code, so you don't have to worry about the code. You will get this code snippet and also the uh, like file. So here you have to concentrate on the code. So first of all, we are importing few important libraries, like we are importing NumPy because we will be using this NumPy to generate lots of data. And then we are using matplotlib. Matplotlib is used to visualize the data. And then we are also using sklearn. So sklearn is also an open source platform or open source library by which you utilize this library to build and to develop lots of machine learning models or machine learning classifiers and regressors. We will be using this to get our data and then split it into train test split. So we will be splitting our data with respect to this train test model into training dataset and test dataset. We will be using again sklearn to import a few libraries like linear regression, polynomial features. These are used to feed your data with respect to different kinds of regressor models. And then we are using mean squared error to check how much is the error between the actual data points and the predicted data points or the best fitted points. Okay, so these are the libraries which we will be importing, or the modules which we will be importing. Now second thing is that we will be synthetically generate data sets. It means that if you have a data set, then you can use that data sets. But right now what I am showing you is that we will be synthetically creating a data set. It means that there is no data set, we are creating the data points synthetically, and then we are working on it. So first of all, what we are doing, we are using this numpy, and then we are creating x, that is independent data, and y, that is dependent data, and that's how we are going to get x and y. So in this figure you will get to know that we are having few data points. We have to create that data points. So in x we are generating the data by using lean space. So lean space means we are generating data in a linear fashion in space with respect to few parameters. Like the first parameters is the starting points, and then this is the end point, and this means the step size. So it means we will be generating 100 data points starting from 0 to 10, and in between there are 100 data points. Okay, so then we are creating y. How we are creating y? So we are using again this numpy, and from numpy we are randomly generating a normal distribution, and we are having these values. The ranges are given and also the step size are given. Okay, so here it means that 0 when you are having a normal distribution, so 0 is the mean, 0.2 is the standard deviations, and these are the number of the data points which we will be creating. And then we are adding it with respect to x, because y is a dependent variable on x, it's not an independent variable, and that is why it's a sin x function. and we are adding it with respect to some random variables, and this is how we are generating x and y. Now we have to split our data sets into different subsets. One will be my training data set and another will be my test data set. Training data set will be used to train my model. We are using a regressor to best fit my model, and on the test data set we will be checking how the model is behaving. That is why we will be using train test split, and we are splitting the data sets, so where we have to give the parameters like x and y as two different independent and dependent variables, and then we are putting test size 0.2 means that we are having from the whole data set we are having 80% of the data into training data and 20% of the data into test data. And random state 42 means we are segregating the data. We are taking 80% of the data into training data set in a random fashion, and we are getting 20% of data set in test data set in a random fashion, and we are creating this. So we are having x train, x test, y train, y test. Now we will be fitting our model. We have to fit with respect to the polynomial regression models with respect to different degrees, because we have these polynomial functions where we'll be taking it with respect to different degrees. First of all, with respect to a linear line we will try to fit our data, then we will increase our degree to degree 4 and we will try to fit our data, and then with respect to higher degree 15 we will try to fit our data. And that is why we are considering 3 degrees of polynomial 1, 4 and 15. And here we are using this matplotlib to create a figure of figure size 12 and 4, and then for each of the degrees we are creating a loop. So it means that here the number of degrees are 3, so for each of the 3 degrees we are creating a loop, and then we are creating a subplot. Subplot means we are plotting our figure but in our different parts. So subplot, first thing is that the row number and this is the column number. So it means that there will be one row and length of degree is 3, so one row and 3 column. So this is the one row and 3 columns are there where we are visualizing our data, and then we are plotting it with respect to I plus 1. I plus 1 means initially the value of y I will be 0, so 0 plus 1 I will be from 1, 2 and then 3. So here we are taking the degrees. So here the degrees are the list, where it is list is having 3 elements 1, 4 and 15. So when the element number 1, that is it is having index 0, and this element will have index, so fourth second element will have this index 1 and this third element will have index as 2. So here we are having different index numbers and we are extracting that values of the degree and we are putting it in that variables. Then we are creating a polynomial features with that degree. So it means that when you are going through the first iteration of the loop, so at that time degree value will be 1, so we will be creating a polynomial features with a degree value of 1, means we are creating a line. So that is why you can see a line is being created when we are fitting our models. And then we will be using fit transform on x train set and also on the x test set, and we are getting x poly and x poly test. From that we will be using linear regression. So linear regression is the linear regression model, and from that class we will be creating an object called model, and we will be using this model to fit our data. Now our model will be fitted on what? On two things. One will be the x and one will be the y. So what is this x? X here is the x poly, so means with respect to the training data set of x, and y train is the dependent parts of that training data set. So we'll be fitting our model with respect to x poly and y train. Y polyprate, what is this? Once you are fitting your model, then you have to predict that how well the model is behaving or how well the model is predicting with respect to x test dataset. This is we are doing to check how our model is actually fitting. We will be getting y polyprate. Now we can compare this y polyprate and actually the x polyprate. So it means that whatever we are with respect to x polyprate, we will have what actual values of y poly. So which is actually here, while we are splitting, we are having this y train data, and with respect to that we have having our y test data. So we can compare the differences in the values between y test and y predicted values, which will give me my error, and from that we can identify whether my model is having high bias or low bias, or whether my model is fitted properly or it is an underfitting, and whether it is an overfitted model. As I have earlier mentioned, what is bias? Bias is the error in the training dataset, and variance is the error in the test dataset. And when it is an underfitting, so what happens in that case? You will have a high bias and high variance. So it means that with respect to the first figure in the left hand side, it means that row number is 1 and column number is 1. So in that case, where my degree of polynomial is 1, we are fitting this data set. So test, what is the test data set? Test data sets are my blue points, and then we are fitting this data with respect to the actually predicted values. So that is my red lines, and we are finding the error, and we are finding that there is a huge error. So both bias and variance are high. So it means that this is an underfitting case. Now, in the second figure, what we are finding is that we are fitting our best fit regressor on the test dataset, where we are seeing that the error with respect to training dataset is not that much, and with respect to test dataset, it is having not that much error also. So it means that both my bias and the variance are low, which is a case of generalized model. Now, if you see with respect to degree polynomial 15, that is here my figure number 3, which is like row 1 and column 3. Here, my regressor is fitting the data in a better way, and with respect to test dataset, what we are finding is that there is some error. So it means that our model is an overfitted models. So in case of overfitting, we are having low bias but variance is very high. Thus, this gives you a clear idea about underfitting, generalized model, and overfitting. Let me tell you that we should always check our bias, variance, whether our model is overfitting or underfitting. And finally, we have to use generalized model to deploy it in real case scenario, so that you can have a model which can generally fit our data in a more generalized way. It will behave in a better way, so that the performance matrices like accuracy, precision, recall, F1 score, these are different kinds of performance matrices, and this will be better in case of generalized model. If you choose a model which is underfitted or overfitted model, so in that case the accuracy, F1 score, these things will not come very good. So to have a generalized model, we should check all of these things, bias and variance, and we can finally arrive to a generalized model, and we'll be using that generalized model. I hope you like this video where I have discussed the practical implementation of it. See you soon in my next videos, where we will deep dive into some other concepts of machine learning. See you soon.